Ngā mihi and welcome to Sector Report and a fascinating look at the developing science of robotics in New Zealand agribusiness. We examine the absence of human hands in two areas, meat processing and milking. First up, we take you to Silver Fern Farms and its Finnegans Meatworks in Balclutha, where a sophisticated system of robots reduces lamb carcasses to their component parts at lightning speed. It's a fascinating glimpse into the future. I also talk to Chris Hopkins, the man who's driven the development of meat industry robotics with his Dunedin-based Scott technology. And we travel to a fully automated dairy farm near Winton in Southland, one of only 10 robotic dairy farms in New Zealand. But first, robotic meat processing. These whirling, ducking, diving and deadly machines may look like the stuff of science fiction, but they're the face of the future for the meat industry. A Dunedin engineering firm specialising in robotics, Scott Technology, has teamed up in a joint venture with Silver Fern Farms, and they've formed a company called Robotic Technologies.
It'll be the first automated boning room probably in the world.
Indeed. No, this is obviously a real international breakthrough.
Over the past couple of years, the company's gradually installed these amazing pieces of machinery and have now assembled a complete production chain with robots breaking lamb carcasses down into their parts. No sign of a human hand.
What stage of development is this whole room in?
So this is a specially built development room by Silver Fern Farms, specifically for us to continue and complete the development of our automated boning room.
Right.
At this stage we've got two elements of the room are commercial products, which is the X-ray system and the primal cutting system, which I'll show you in a minute.
Right.
The other parts of the room are all currently being commissioned for the final stages of production before they go into production. So by the end of this season, I would expect this entire room would be in full production.
At the first stage in this robotic dance, each individual carcass is X-rayed for an incredible array of data that are sent on to the robots. We could only enter the lead-lined space when it wasn't hard at work.
Okay, well Andrew, we're in the X-ray room now because the plant's shut down for smoko, so we could quickly get in here. Can you just explain to me how this X-ray machine works as the sheep come past?
So the carcasses are coming from pre-trim, they come into the X-ray room, they come past the tube, which is in this room here, and that's emitting X-rays across to the detector, which is here, 2 metres long. We take a full scan of an entire animal as it goes past, then we turn it around so that the orientation's the same, bring it past again and raise it up 600 millimetres, take a second scan, and then we use the two images and combine them to get 3D information for rib angles and so on. And then those animals go directly into the boning room and into the primal cutting system.
Right, so in other words, all the data that this X-ray has just picked up goes to those robots there,
yes,
basically to cut the lamb up with an incredible degree of accuracy.
After their X-rays, the carcasses meet their first robot with a vicious pair of circular saw blades which slash crossways through the carcass, dividing it into forequarter, saddle and hindquarter. A computer determines if the carcass has 12, 13 or 14 ribs. Yes, lambs don't always have the conventional 13, and a robot needs to know that. Now, take a look at what one of these machines does to a forequarter.
Forequarter is coming from the primal system.
Yeah.
It's placed on an interface plate.
Right.
The robot will grab hold of it, and because every animal's different,
Yeah.
we then have to scan the forequarter to generate a three-dimensional model of it. From that, we analyse it and determine all the cut points to split that animal up.
So it's now cut it up into its component parts.
That's right.
What is the ultimate aim with the cuts that you've got here? They'll go on a conveyor belt through to be handled by human beings.
Correct, that's right. So from here, in the case of the forequarter, basically all the bone-in cuts are complete. And if they're going to have a boneless product, then they'll be done by hand, but all the bone-in product is done on this machine.
The joint venture company is already commercialising parts of this process, with Alliance at Lawnville and the Takapau Works using it, along with an order from Australia. Silverfern Farms is delighted with its robotic processing system.
There's actually a lot of advantages, John, in terms of why we got into it. First one was safety, and that, as you've seen out there, most of those jobs were previously done by bandsaws, and obviously that's inherently risky. So that's the first thing. We've taken out just about, well, most of the bandsaw jobs, and eventually we'll take all of them out. The second one is about yield. As you've seen, very accurate cutting of the primals, and that basically means more of the meat on the valuable cuts and less wastage. And also customer quality. With accurate cutting, we can easily achieve the specifications of the customers, which is obviously critically important.
Of course, when any operation like yours becomes more automated, there are fears among the workers that they're going to lose their jobs. Has that actually happened here?
Well, there's certainly a labour saving, which is an advantage for us, but there's been no redundancies or loss of jobs out of this, and the reason for that is that here, and certainly at our other plants, there's a labour shortage. Even in the recessionary times, we still struggle to find sufficient skilled staff. So basically we're freeing up employees from bandsaws and related tasks and moving them on to more skilled jobs like boning and other packaging type jobs.
And what will this mean for the people who actually produce the lambs that you process, the farmers?
Well, that's the other aspect of what you've seen. The X-ray part of the process not only provides the cut positioning for the robotics, but it also provides feedback to farmers. So those farmers that invest in EID tags or RFID tags in the ears, we can use that information to trace the X-ray information back to the individual animal. So breeders and so on can get very accurate information about the yielding of their animals and different attributes that are valuable to them. For example, certain lambs actually have 14 ribs, not 13 ribs, and that might be an attribute that a breeder wants to work on, so we can provide that information to them. And also the weight distribution to the different parts of the carcass, which is also of value to us in terms of providing the types of cuts the customers are after and better yields.
A sci-fi glimpse into the robotic future for the meat industry there. In a moment, I talk to the man who runs Scott Technology about the robotics his engineers have developed for Silverfern Farms. Meet Chris Hopkins in his company's Dunedin workshop. Well, Chris, welcome to the Sector Report program here on Country 99 TV. Now, just tell me about Scott Technologies. How long have you been around and what do you do?
Scott Technology, we've been around a long time now. We started in 1913 here in Dunedin, so we're coming up 97 years. So looking forward to our 100 year in a couple of years' time. And what we do is we've obviously done a lot of things and morphed over those 97 years. So what we do today is not the same as we did 97 years ago, but what we do now is we're really automation and robotics engineers. So we solve solutions and or solve customers' problems, provide them automation solutions.
Now, we've been to Silverfern Farms out at Balclutha today and looked at your very impressive robotic operation. Now, I realise it's still a bit of a work in progress. How much is it a work in progress? When will you finally have the real product?
Parts of it have been work in progress or have been beyond a work in progress. We started on the whole project about 8 years ago. So some of the components you saw, like the X-ray and the primal cutter that separates the carcass into 3 pieces, that is now a commercial product. So it's past a work in progress. That is now fully commercial, and we have a system operating at Alliance and Invercargill. We have 2 systems running at Silverfern Farms, and we're currently building another system for an Australian processor.
How much interest have you had from the meat industry?
It's been, well, there's an enormous amount of interest. So certainly all the processors are very interested to see what's happening and where the future might lie. So there's a lot of drive on for increasing productivity, for yield improvement, And let's face it, most of our equipment is driven at yield improvement. It's about getting more meat off the bone. And of course that has a lot of interest to all the meat processors who have been through some tough years, and if they can get more meat off the bone, then it's good for the company, good for the farmers. So there's a lot of interest outside New Zealand and Australia as well.
So the IT component, if you like, does computer systems designed to replicate the movements of a human hand must be very demanding to try to develop.
Yeah, and technology's helped us in that area as well. So when we first started out, we knew very little about the meat industry, and we relied on our partner, our joint venture partner, Silverfern Farms, to help us with the meat processing side, because a lot of our other automation is trying to do something exactly the same and repeatable and make exactly the same product. We looked at this as a disassembly operation, but of course we sort of say it's a naturally varying product, and everything is precisely different rather than precisely the same. So it was a big challenge, and the key for us was around the imaging and the sensing technologies, and which has been a major breakthrough to enable us to treat every carcass as different.
So is information technology an important part of this whole manufacturing process that goes on here in this workshop?
IT, we call it controls, but it's a system control, so it's electrical and the electrical mechanical side of our business is critical. But we've also diversified into some other areas around the image processing. Has also been quite a major development for our industry.
That's getting the information in that image into the brain, if you like, of the robot.
Correct, and making something of it, because we're capturing a digital image, like a digital X-ray image or a 3D scan, and we then have to analyse that in real time using computer processing technology and making assumptions and a very smart learning system to actually interpolate that. So it's been quite a challenge, but quite exciting on the way through. We've started doing some work with Silverfern Farms, our joint venture partner, on the beef as well as beyond the lamb. Lamb was our first target, and we've now started to transfer some of that technology and learnings from lamb into the beef industry. We have a joint venture with an Australian beef processor to get access to their facilities and their learnings. So we've already got multiple projects underway in the beef sector at the moment, and we expect that will be an increasing part of our business.
So what sort of a challenge was it to develop this robotic processing system?
Well, I think the 8 years in developments probably tells a big part of that story. It was a lot slower and a lot harder than we first imagined. So we came in very naive, thinking we can do this, and I remember we tabled a very sophisticated complete boning room solution and said, this is what we'll provide you, and they said, well, okay, well, maybe we'll take one step at a time, and I think it was quite wise.
Now, you probably would have been using skills that you probably hadn't thought you'd need to get. I think you said to me you've got a man who's a PhD in mathematics on your staff, for instance. Has it been hard to get the right people?
Yeah, and yes, I mean, our skill set has changed over time. We've now got people with mathematics and physics in their background, so we supplement our engineering and controls and electrical, mechanical side with other skill sets. But that's been quite enlightening too, to actually expand the skill base that we have within the business.
Now, you're working on this with Silverfern Farms. Can you just explain the commercial setup with that meat company?
Yeah, we've tried to keep it fairly simple. We basically say we're engineers and we don't know anything about the meat industry. Silverfern Farms bring the meat processing expertise and skills, and so we see it as a very good marriage between those two. And so we've got a joint venture that's called Robotic Technologies, and that's owned 50% by Silverfern Farms and 50% by Scott Technology. And so all our activities are shared, and we work on them jointly.
What else has Scott Technologies got on the go at the moment?
Right outside the meat industry, in terms of, well, we're doing a little bit in the agriculture related. We're still doing some work in the viticulture industry. We're working with the University of Canterbury on their automated vine pruning project. We're doing some preliminary work in the aquaculture sector.
Yeah.
And so.
Anything else on the horizon? We're not going to see automated sheep shearing.
No, a lot of people have asked for that, but no, I think there is a limit, and I think one of the secrets is trying to know your limits. So, yeah, that might be a 2020. Yeah, I'm not talking about the vision, I'm talking about the years. So a long way off. But
Well, things like robotic meat processing must present some pretty good export opportunities for you.
it does. We're working mainly, the lamb and beef areas that we're working on at the moment is mainly New Zealand and Australia, and we see Australia as very much sort of a domestic market for us, and don't see that as in the traditional export. So the export markets, we already have some beef processing equipment in Brazil at the moment. We've also shipped some to Ireland recently. Later this week we've got some visitors from the UK coming and from the US as well. So again, it sort of reflects the international interest. But also that international interest will translate into export opportunities for our technology and for the company.
Well, how do you see robotic technology across the board developing in our agricultural industry?
I think it's got a bright future. I mean, if you're talking about increasing productivity, and there's a lot of talk about productivity gains, one of the ways to achieve productivity gains is by using smart automation. And I think the technologies are now such that the smarts are coming. And by smarts, I mean touch and sense and replicating some of the human senses. And that interface with smart robotics or smart machinery means that the opportunities are really limited just by your imagination in some ways.
Chris Hopkins of Scott Technology there. I'll be back in a moment with another glimpse into the farming future with a visit to Bill Alfagal's robotic dairy farm near Winton. The cows graze, come in for milking and return to their paddocks whenever they feel like it, all without the touch of a human hand. In they come when they feel like it's time to be milked and get a feed. But these cows are reposing their faith not in humans, but robots. That doesn't seem to worry them though. They willingly enter the bale, known as a voluntary milking station robot, an average of just over twice a day. The owners of this robotic dairy operation of around 350 cows, Bill and Janet Alfagal, also have another herd of 550 which are milked conventionally. But the showpiece is their row of 4 robotic bales. The Alfagals moved to New Zealand 10 years ago after trying to get ahead in Holland's dairy industry with its small herds.
I like a challenge in the dairy industry. And what I see is all the robot milking over 20 years. And I like it, what you can do with the cows with the robot milking. That's the reason why I do the robot milking.
Now, you came here from Holland
Yes.
10 years ago.
Yes.
Did you come here with the intention of setting up a robotic operation?
No, more for the challenge and more opportunity here in New Zealand.
And I guess you'd be able to run a bigger herd than you could
That's right.
back home.
Yeah, that's right. In Holland we run a herd for 60 cows.
So what's it cost to set up an operation of your size with some 350 cows?
You're looking only the robots and all the setup, all the computer stuff and the grazing ways and the gates is around $1 million.
Around $1 million?
Yes. Don't look at the buildings. The building, you can make the building different what you like to do. You make it cheaper, expensive. How big? It's all personal.
But it's not a cheap option, is it, for a dairy farmer to convert to this?
Well, you have to look at different ways, over long term, You say you do with the robot milk, you save on labor and on animal health. You do less lame cows, less mastitis cows, there's no pressure for the cows. You do 20% more production.
20%?
20% more production than in a normal farm.
Such has been the increase in production from robotically milked cows that Bill proudly points out his operation has passed a milestone with the production of 10,000 litres of milk a day from the 4 robots, trade name Astronaut, and produced by the Dutch Lely Farm Machinery Company. While we were filming at this robotic farm, a busload of Australian dairy farmers arrived. They're suppliers to Fonterra's operations in Victoria and Tasmania. The Aussies liked what they saw, but the money involved could be a barrier to some.
We just don't know what the future's going to bring, so...
Yeah. Would you ever entertain putting in one of these yourself?
Oh, you'd have to look at it. I already have, so...
You've already got
No, I've entertained looking at them, so... But I'm just not sure. It's still up in the air.
Yeah.
In the next couple of years, we aim to do something, so...
Definitely the way to go, but yeah, it's just that cost that stops a lot of us. Yeah.
I've never seen it before. No, it's very interesting.
Yeah. Costs a bit of money, though.
It does. It does.
Yeah.
But not as much as I was thinking either.
When a cow decides it's time to be milked, and that can happen in the middle of the night, she enters through a race with a sophisticated computer mounted to track the animal as she passes underneath. Bill showed me how it works. Well, Bill, I can see the cows have got these responders just there on the collar.
Yes.
Now, when they come in this entrance here, what does the job that responder does when they come up here to go in to be milked?
When the cow comes through here, Crazeway,
Yeah.
it reads in a couple of seconds this computer.
Yeah.
Is the cow due for milking or not?
Right.
Is she due for milking, she goes straight
Yeah.
to the robots.
Yeah.
She is not due for milking, she goes left.
And that's this gate here.
Yeah, swings over.
So that gate swings.
Yep, swings over.
Okay.
Yeah, full automatic.
Yeah.
And when she's not due for milk, she comes in the post-milking.
Right.
And she can do a drink.
Right.
And she can go out back to the grazing or she wait for the next grazing.
Right. Okay. Yeah. So either she'll wait to have another go, or else she'll go out to the paddock and graze.
Yep.
Yeah.
That's right.
And so this computer must be able to read a lot of information off that responder.
Everything.
Right.
Everything what you need for the cow.
Do many cows actually try to get in, even though they don't need to be milked? They're just feeling a bit greedy, they want another feed? Do many of them come in like that?
No, not really. No. The cows know when the cage is ready for straight.
Right.
Yeah.
Right. So they're intelligent enough to have, and I guess it's also a question of routine. After sort of 12 hours or so,
that's right.
they're ready to be milked.
Yeah. Every 8 hours.
There are 5 robotic dairy operations in New Zealand. The 2 makes are De Laval and the Dutch Lelies. In addition, there's work going on in Australia to develop a robotic system using a rotary platform, although existing rotaries can't be retrofitted for robotics. The developers, De Laval, claim a rotary system will cost considerably less than a single box setup, although they won't reveal any figures yet. Bill Olfagau, however, is perfectly happy with his single box robots. I asked him if the robotic system requires cows with a particular temperament.
No, you can elk type of cow you can do milking to the robots. Yeah, it's not a matter.
So it doesn't matter, the personality of the cow just doesn't really matter. Yeah. They do seem very placid though, don't they? This seems to produce a very calm kind of placid.
Yeah, really calm. You know, the cows, there's no pressure for the cows, you know. That's what the cows like, home by themselves.
One thing I've noticed in a normal dairy shed during milking, you've got hoses going all the time, hosing all the effluent away. How do you keep the yards clean here?
We do that every morning. This depends what you like to do. You can do the night or afternoon, but we do that every morning.
Right.
Yeah, take an hour, clean the whole lot, the 4 robots.
Now, the cows each have a sensor around their necks.
Yes.
What is the information that sensor gathers?
Everything.
Everything?
Everything for the cows.
Yeah.
Like? Heat detector when the cows come on heat. Milking time, when the cows coming in the barn here. Mastitis, everything, which will animal health.
And that's our program looking into a robotic future. I'll be back soon with another sector report. And remember, you can catch up with the program on our website. See you next time.